Hello dear, how are you? We have a simple problem. A piece of wire 30 centimeter long is to be made into two frames. The wire is cut into two parts. One part is bent to form a circle with radius r centimeter, and second part of wire is bent to form a scale of side x. Question is this: we have to show that combined area of circle, which is made by one part of wire, and area of scale, which will be made by the other part of wire. We have to show that combined area of both shape is minimum. Question is this: we have a wire having its length 30 centimeter. We cut into two portions. We cut into two parts. For example, we have a wire. We have a wire of its length 30 centimeter. We cut it from here. We cut it into two parts. We cut into two parts. One part is used to make a circle of radius r, and other part is used to make a scale of radius of side x. One part is used to make a circle of radius r, while other part is used to make a scale of side x. This part we use to make a circle of radius r. Radius r, we know, right? We here write length of string, length of wire, which is 30 centimeter. We cut into two parts. One part is used to make a scale, to make a circle of radius r. We have to make a circle of radius r. If we have a circle of radius r, we easily can find the total circumference, total length of from this point to its last point. I mean to say, we can easily find the circumference of circle. Circumference of circle, which is always equal to 2 pi r. Circumference of circle, which will be 2 pi r. It means length of one part of wire will be equal to 2 pi r. Length of one part of wire, which will be equal to 2 pi r. Because this circle, its circumference is 2 pi r. We now want to find the length of other piece of wire, which will be equal to total length, that is 30 centimeter minus first part of wire. The length of other piece of wire. The length of other piece of wire, which will be equal to 30 minus 2 pi r. By this length of wire, we want to make a scale of side x. Finally, we find the scale of this area and scale of this area. We have to find we have to find the combined area, combined sum of two areas, area of circle plus area of scale. We have to minimize the area of circle and area of scale. This is the length of second part of wire, and we want to make by this part a scale. We know that perimeter of scale, which is equal to 4 multiply one side. 4 multiply one side. This will cover total perimeter of scale. This length would be the total length of perimeter of a scale. Is it clear? We know right here. The length of second part of wire, which will be 30 minus 2 pi r. Circumference of circle, which is 2 pi r, it is the length of first piece of wire, which will be equal to the length of first piece of wire, and the length of second piece of wire will be 30 minus 2 pi r. We now find the area of circle. Area of circle. Area of circle, which is pi r square, and when we make a scale, perimeter of scale. Perimeter of scale, which will be equal to 4 multiply one side. 4 multiply one side. 4 multiply one side. We have to make a scale of side x. Here we write 4x, and perimeter of scale, which will be the total length of second part of wire, which is 30 minus 2r. 2 pi r. We can define value of x, which is 30 minus 2 pi r divided by 4, and x is equal to, by taking 2 common, 15 minus pi r by 2. From here we can easily find the value of r in terms of x. We will find the value of r in terms of x. 2x into 15 minus pi r. To find r, pi r 15 minus 2x, while r is equal to 15 minus 2x divided by pi. We use these two values of r and x to find the combined area. We now want to find the combined area. Combined area means that the area of circle, which is pi r square, we replace the value of r here, and we find the area of scale. Area of scale means side multiply side. We write here let A be the combined area of circle and scale. Capital A is equal to area of circle plus area of scale. We can write area of circle, which is pi r square, plus area of circle, which is side multiply side, and side of scale, which is x, side of scale, which is x. We write A is equal to pi r square, x multiply x, which is x scale. Okay, we can write x scale. We know write the value of area in terms of x. We write it A is equal to pi. Value of r, we take the value of r, 15 minus 2x by pi, replace here. 15 minus 2x, 15 minus 2x by pi whole square plus x cube. We write A is equal to pi multiply. When we expand this scale, we get 15 scale, which is 225 plus 4x square minus 60x divided by square of pi, which is pi square, plus x square. After simplifying, we get 4x square minus 60x plus 225 by pi, because 1 pi is cancelled from here, plus x square. By taking LCM, we get A is equal to 4x square minus 60x plus 225 plus pi x square divided by 4 pi. We again write A is equal to 4x square plus pi x square by taking x square common, 4 plus pi x square minus 60x plus 225 by pi. We have to minimize this area. We will differentiate this with respect to x. We get dA by dx, pi which is constant will remain same, 1 by pi multiply x, derivative of x which is 2x, we write 2x pi plus 4 minus 60, derivative of x which is 1, and derivative of 2.5 which is constant 0, divided by, we have already pi as 1 over pi. Here we put dA by dx is equal to 0, implies that 1 by pi 2x multiply pi plus 4 minus 60 is equal to 0, implies that 2x multiply pi plus 4 minus 60 is equal to 0. From here we get 2x into pi plus 4 is equal to 60, and we get x is equal to 60 by 2 into pi plus 4. We get x is equal to 30 by pi plus 4. Here we write value of x, which is 30 by pi plus 4. We will check whether x is minimum or maximum. We have to differentiate again dA by dx. Where is dA by dx? We differentiate again it with respect to x, d2a by dx. By again differentiating d2a by dxk, pi again as a constant, 1 by pi again as a constant, 1 by pi, derivative of x which is 1, 2 multiply pi plus 4 minus derivative of this 60 which is constant, 0, d2a by dxk at x is equal to 30 by pi plus 4, which is always positive. We can write which is always positive. Hence, x is equal to 30 by pi plus 4 is minimum. From this, it is clear that when the value of x is the minimum, it will give the minimum value of area. It shows that combined area of circle and scale will be minimum. This will prove. After this, we have to find the length of first part of wire and the length of second part of wire, which minimize the area of both. We don't want to find the length of first piece of wire and second piece of wire. Length of first piece of wire, which is 2 pi r, and length of second piece of wire, which will be 30 minus 2 pi r. We know find the length of first piece of wire. Length of first piece of wire. Length of first piece. Length of first piece, which is 2 pi r. 2 pi r, and the value of r, which is 15 minus 2x divided by pi. After cancellation pi, we get 30 minus 4x, and we know that value of x which is 30 by pi plus 4. When we take LCM pi plus 4, we get 30 pi plus 120 minus 120, 120 minus 120 by pi plus 4. Pi plus 4, we get 30 pi divided by pi plus 4. This will be the length of first piece of wire. We now find the length of second piece of wire. This will be the length of first piece of wire, length of second piece of wire. Length of second piece of wire, second piece of wire, the second part of wire, which will be equal to 30 minus 2 pi r. 2 pi r. We write 30 minus 2 pi, value of r, which is 15 minus 2x divided by pi. After cancellation pi, 30 minus, we get when we multiply 2 by 15, 30 minus plus 2 to the 4 x. After simplification we get 4 multiply x, value of x which is 30 over pi plus 4. We get 120 over pi plus 4, which is the length of second piece of wire. Thank you.